So the last part of our unit is being able to completely solve polynomials. So our fundamental theorem of algebra tells us that we should have the same number of answers as whatever the highest power is. And it can be any combination of real, rational, irrational, or imaginary numbers. Okay, so again, we need to remember that multiplicity is when a root is repeated. And then our irrational, so our square roots, and which also implies our imaginary, since that I represents the square root of a -1. Those are always going to come in a pair. So a positive and it's negative. Okay. And again, we know that because when we start solving, we would have to write in that square root, and then two numbers that would multiply to get, so let's say 64, for example. I can take 8 times 8 to get 64, or -8 times -8. So we have to remember to include both the positive and the negative answer for these. So that's why we always know that those types of answers come in a pair. Okay. And then our rational zero theorem determines possible rational zeros of a polynomial. So this part is new. So what we're going to talk about in this next section is how to actually come up with this zero or factor. Okay. So in our previous section, we were given that. So now we need to be able to come up with that number. Okay. Now again, why is this important? So it's important because if something can't factor easily following our patterns, being able to find that zero and then do the division part of it allows us to factor it when it doesn't fit into that nice pattern. Now we are going to be using our calculators, or you're going to be given the picture on the calculator to be able to come up with those rational answers, those rational zeros. Now remember, when I'm using the word rational, that refers to either a positive or negative whole number or a positive or negative fraction. So if it's an irrational number, we're not going to be able to find those right away. So we always have to start with the rational answers first, and then based on what our answer looks like after we do the division, that will determine the other types of answers. And we can usually tell that too based on the picture that we can see on our calculator. Okay. Now if we can't find a rational zero and we can't factor it, then again, we don't have the tools right now to be able to solve these types of problems. So that's something that you're going to talk more about next year. Okay. So what we are going to do is use this rational zero theorem to give us a starting point to figure out this type of number, that rational zero. Now again, this is just a starting point. It doesn't actually tell us what that rational zero is. So we are using this type of formula to come up with the possible rational zeros. Okay. So we're going to take the factors of the constant divided by the factors of our leading coefficient. Okay, so that's what we're going to practice next. Okay. So as I'm looking at this, the 1 is the constant. So all the numbers that multiply to be a 1 would be a positive and a -1. And then the 2 is the leading coefficient. So all the combinations that we can multiply together to get 2 would be a +1 and a +2, or a -1 and a -2. So basically what we're doing is we are coming up with a list of every single number that divides into the constant, and then every single number that evenly divides into our leading coefficient. Okay. And then our possible rational answers come from using this fraction. So I'm going to take each number that I listed out for my constants and divide it by each number in that leading coefficient. So 1 divided by 1 is 1, and I need to keep that positive and negative number there. And then I go to my next one. So 1 divided by 2 is 1/2. Okay. So if this does have a rational zero, it has to be one of these four numbers. Okay. So let's try another one. So again, starting with the constant. So that's 5 this time. So all the numbers that divide into 5 are positive and negative 1, and then positive and negative 5. And then for the leading coefficient, which is 4, all the numbers that divide into 4 would be a positive and negative 1, positive and negative 2, positive and negative 4. Okay. So now my list of possible rational answers. So again, I'm going to take each number in the constant and divide it by each number of the leading coefficient. So I'm going to go through and I'm going to take 1 and I'm going to divide it by each of these. So 1 divided by 1 is 1. And then I would divide it by 2, so that's going to give me a 1/2. And then 1 divided by 4 is 1/4. Okay. And now I'm going to go through and do the same thing with this next one. So I'm going to take 5 and divide it by 1, which is positive and negative 5. 5 divided by 2 is still a fraction, so I'm leaving my answers as fractions. I do not want to write decimals. And then 5 divided by 4 is 5/4. And I have to write that plus minus in front of each to account for both the positive and the negative. Okay. Now really the order that you write these in doesn't matter, but I would find a consistent way to work through your lists so that way you don't accidentally miss something. So another way to do it is to go through and divide each of these by 1, and then go back and divide each of them by 2, and then each of these by 4. So we would still have the same numbers, just our order would look a little bit different. So again, the order that we write them in doesn't matter. We just want to make sure that we are accounting for all of the possible answers. Okay. Now, to find the rational answers, if they do exist, we would then type this into our y equals and look at our picture to figure out if it's crossing at any of these numbers. So we'll talk about that in a later video. Okay. So let's just continue with our pictures here. So that way you can, once we do use our calculator, you can see what our end goal is. Okay, so again, for these problems, we are finding all of the zeros of the function. So if we were stuck, our starting point would be to make our list of the constants. So that would be a positive, a negative 1, positive, and negative 3. And then all the numbers that divide into the leading coefficient, which is a 1, would just be positive and negative 1. And then our possible answers, so 1 divided by 1 is 1, and 3 divided by 1 is 3. And then again, I need to include that plus minus to account for the negatives. So if we have a rational answer, it has to be from this list right here. So at this point, I would type this equation into my calculator, and that's what this picture represents. Okay, so as I'm looking at it, it's crossing at 3 here, which is on my list. So that means that my rational answer is going to be 3. So at this point, if I'm solving, I have found one of my 3 answers. Okay. So as I'm looking at this picture, because it doesn't cross anywhere else on that x-axis, that tells me that my answers have to be imaginary. So the only way to find them is to go through our division. So I'm going to take the 0 that we just found, and I'm going to divide it into my original problem. So this will be 1, negative 3, 1, negative 3. So again, go ahead and pause your video and finish out this division. Now, because I know that this is a rational answer, we should be getting a remainder of 0. So if we're not, something is off in our problem. So right now this will be x squared plus 1 when I write it. So that's one of the factors. And then if my rational 0 is 3, so again I'm thinking of that as equal to x, so I would subtract that over. So technically that's x minus 3. So this would be our factored form. Okay, now this part we've already solved. That gives me that 3. So now I need to focus on solving this piece right here. So that x squared plus 1, I'm just going to set equal to 0. Now based on what this equation looks like, determines our next step. So here, because I only have 2 terms, that means that I can just subtract that 1 over. And then I can take the square root of both sides. So because we are solving and we wrote in that square root symbol, I need that plus minus. And then the square root of -1 is I, okay? Which is our imaginary number. So as I'm looking at this, my answer is a positive I, a negative I, and then 3 based on my picture here. So I have 3 answers total, which is what I needed because I started with that cubic equation. So at this point, I have completely solved the problem and I'm done. All right, so if we keep going, now again, just to make sure that we are understanding what's going on with that picture, so that the constant is our 20. So all the numbers that divide into 20 are 1, 2, 4, 5, 10, and 20. And then our leading coefficient is 1. So then our possible answers, so I'm just taking each of these and dividing them by 1, so that's actually not going to change. Now you do not have to include this as part of your work. This is just a way to check to see if your rational answer makes sense or answers make sense. So that again we're going to get based on our picture. So notice how in our list of possible answers I don't have any fractions. So that means if we have a rational answer on our picture, it has to go through one of those tick marks evenly. Okay, so the only place that is happening is right here, which is at 1, 2, 3, 4. So that means that my rational answer would have to be 4, which is on my list. So as I'm looking at this picture, that means that where it's crossing here and here, those are going to be irrational answers. So we should have a square root in our last 2 answers. Okay, so I need to go through my division next. So we're just taking our rational answer and dividing it into that. So 1, -11, 23, and 20. Okay, so again, go ahead and pause the video and finish out your division. And when you get to the end of this, again, we should have a remainder of 0. So if we are not getting that, that means that something went wrong in our work. Okay, and I did get a remainder of 0, so that's okay. Okay, now this time I'm not going to write it out in that factored form like I did that previous one. I'm just going to take this and write it back into an equation. So x squared minus 7x minus 5. And then we always set it equal to 0. Now as I'm looking at this, because I have the 3 terms, that tells me that we need to solve either by completing the square or by quadratic formula. So because this is an odd number, I'm going to choose the quadratic formula. So remember, this is our a, our b, and our c. And the quadratic formula is that x equals opposite of b plus and minus the square root of b squared minus 4ac all over 2 times a. So this will be positive 7 plus and minus the square root of 7 squared, so 49, minus 4 times 1 times -5, and then all over 2 times 1. So now we are just working on simplifying that. Okay. So that just means that I'm typing what is underneath my square root into my calculator. So 49 minus 4 times 1 times -5. And make sure for the -5 that you're using the negative key at the bottom of your calculator and not your subtraction key. Okay. So we have 69. And as I'm looking at that, I cannot simplify the square root of 69 any further. So I'm just going to leave it as that radical. And remember, this counts for 2 answers because of that plus minus. And I need a total of 3 since I had a cubic equation to start with. So that third answer is that rational answer that I found at the very beginning of the problem. All right, so let's keep going. All right, so next as I look at this, again, if you need to, we're going to start with our list of all the numbers that divide into the constant. So plus and minus 1. Positive and -2, 7, and 14. And then for the leading coefficient, that's -1. So that would just be a positive and -1 that would divide in there evenly. So our possible numbers for the rational answers, again, I'm just taking each of these and dividing it by 1. So that's not going to change anything. Okay. So that tells us that our rational answer, or answers, has to be a whole number. So it has to go through those tick marks evenly. So as I'm looking at this, it's crossing here at -1, and then here again at +2. So this time I have 2 rational answers. Okay, now that's a good thing because we need a total of 4 answers. So if I only found 1 rational answer, that would mean that something is off in my picture. Okay. So because we have 2 rational answers, that also means that we're going to have to do our division process twice. And it doesn't matter which one of these you start with. So I'm just going to use the first number that I wrote down. And we are dividing that into the original. And notice how we skipped our squared term. So I need to make sure to put in my 0 placeholder in that spot. So I'll have the 0 and then 17 and 14. Okay. So go ahead and pause the video and complete the division, but don't put your equation, your answer back into an equation. And again, if we're not getting 0 for the remainder, that means something is off in our problem. Okay. Now, because we divided once, right now this represents a cubic equation. But again, our goal is to reduce it to a quadratic. So now what I'm going to do is I'm going to take my second answer and divide my new equation by it, except for the remainder. So I'm going to cross the 0 off, and then I'm going to divide my next rational answer into this equation. Okay. All right, so again, go ahead and pause your video and complete the division. And again, we should be getting 0 for that remainder. And this time, we do want to put it back into that equation. And then we are setting it equal to 0. Okay. Now, another approach that you could take to this is by putting these into its linear factors, multiply them together, and then you could use long division with that answer and divide it into that original problem, and we would still get this for the same correct answer. So there is more than one right way to work through these problems, but typically the synthetic division is the fastest way to do that. Okay. Now, as I'm looking at this, I have 3 terms, so that tells me that we need to continue with, and hold on, I forgot my negative. That could have been bad. That tells me that I need to continue with the quadratic formula. So again, this will be A, B, C, and that formula is x equals opposite of b plus and minus the square root of b squared minus 4ac all over 2 times a. So this will be x equals positive 5 plus and minus the square root, and then 5 squared is 25. Minus 4 times a, which is -1, times -7, and then all over 2 times -1. So now we are just working on simplifying. Okay. Now, as I'm looking at my picture, because it's only going through this line twice, that tells me that my remaining 2 answers have to be imaginary, because I can't see it on the graph. So again, at this point, I'm just simplifying this, so I'm typing that all in. So 25 minus 4 times -1 times -7, so -3. Okay, so because of that negative, that's going to give me the I. So this will be 5 plus and minus I square root of 3 over -2. And remember, we don't want the negative in the denominator, so I'm just dividing everything by -1 to force that to become a positive. So this will be x equals -5 plus and minus. And then because of that plus minus, I'm not going to write the negative. So this is still going to be I squared of 3. And then over a positive 2. So this represents 2 answers because of that plus minus. And I need a total of 4 answers. So the other 2 are what we found at the beginning. So -1 and positive 2. So here are all 4 of the answers. All right, one more. Okay. So this time I'm not going to write out that list. And part of that is because anytime this is a 1 here, all of my possible rational answers have to be factors of my constant. That tells me that I need a whole number. So I'm just going to figure out what those rational answers are. So it has to be going through one of the tick marks nicely. So it looks like it'll be this one. So that's at 1, 2, 3, 4. So -4. And then the other place where it's going through nice is here. So 1, 2, 3, 4, 5, 6. Okay, so that tells me that these answers have to be irrational. So that means that after we do our division, when we get our final answers, we should have a square root. So just like in that previous problem, I'm going to need to do the division twice. And it doesn't matter which one we start with. So I usually just start with whatever number I write down first. So -4, dividing it into that original problem. And we didn't skip anything this time, so I don't need to worry about that 0 placeholder. So again, we're just doing our synthetic division. So if you need to pause the video, go ahead and pause. And I should be getting that 0 remainder, so I did. So now I'm going to take my second answer and divide it into this, crossing off the remainder. So again, if you need to pause the video to do the division, go ahead and do that. And we should also be getting a remainder of 0 for that last one. And then we are putting this one back into that equation. So x squared minus x minus 5, setting it equal to 0. Now to check to see if we got this right, if we are dividing twice, that means that the original exponent should be reduced by 2. So 4 minus 2 is 2. So that's how I know that I did this right. And we should always be getting that quadratic equation there. Otherwise, remember, we're not able to continue solving. Now, because we have those 3 terms, that tells us that we either need to use the quadratic formula or complete the square. So again, I'm just going to use the quadratic formula again. So we will have x equals 1 plus and minus the square root, and then 1 squared is 1, minus 4 times 1 times -5, all over 2 times 1. So now we are just working on simplifying that. So 1 minus 4 times 1 times -5 is 21. And we cannot simplify the square root of 21, so we are just going to leave it. So this represents 2 of my answers, and then the numbers that I divided by are the other 2 answers, so that -4 and 6. So here is all 4 of those answers.